Now we move from DePIN theory into real networks. We'll look across wireless, compute, storage, sensors, mapping, and data projects to see how incentives, hardware, demand, and operations come together, and what practical lessons builders should carry forward. You now have the core lenses for evaluating DePIN: fundamentals, incentives, architecture, go-to-market execution, operations, and regulation. Next, we'll apply those lenses to real projects. As we go, look for patterns: what worked, what failed, and which lessons should shape your own capstone network design. Before comparing projects, use one consistent lens. Start with supply. Who contributes infrastructure, and why would they keep doing it? Then look at demand. Who pays for the service, and how often? From there, evaluate proof quality, because rewards only matter if the network can verify real work. Finally, test the economics, operations, and regulatory constraints. Sustainable networks are not just well incentivized. They are useful, measurable, scalable, and built for the real world. Helium is a major DePIN case because it showed that people will install real hardware when incentives are clear. Token rewards helped bootstrap LoRaWAN coverage for IoT at impressive speed. But coverage by itself was not enough. In many areas, user demand arrived more slowly than supply. Helium's shift toward 5G and mobile highlights the next challenge: turning decentralized infrastructure into services people consistently pay for. Wireless DePINs are often very good at creating supply. Token rewards can motivate people to install radios faster than real customers appear. But useful coverage is different. It has to be in the right locations, dense enough, compatible with devices, and reliable over time. The hard part is converting mapped coverage into paid traffic. That usually requires simple hardware onboarding and partnerships with carriers, enterprises, IoT platforms, or app developers. Connectivity DePIN is not a single market. IoT networks optimize for wide, low-cost coverage, but demand can take time to develop. Community Wi-Fi and mobile offload can monetize higher value traffic, so reliability and user experience matter much more. Bluetooth and phone-based models reduce hardware friction, but still have to prove the data is real and useful. The winning design starts with a specific wedge market, not abstract coverage everywhere. Filecoin is a useful reality check for decentralized storage. Its proofs can verify that providers are storing data over time, and token incentives helped attract huge capacity. But capacity is only half the market. Customers also care about fast retrieval, reliability, simple developer tools, and easy integration. To win, decentralized storage must compete with cloud providers on everyday usability. Arweave shows a more focused path for decentralized storage. Rather than trying to replace every cloud workload, it targets data that should remain available for years: archives, NFT media, public records, and application assets. That narrower promise can create stronger product-market fit. But permanence is not magic. The economics must fund storage far into the future, and developers still need simple tools and integrations so permanent data is easy to use. Akash and Render show why compute DePIN is more than finding spare servers. Akash aims at cloud-style deployments, where scheduling, uptime, pricing, and developer tools matter. Render began with GPU rendering, where demand is specialized and easier to define. The lesson is straightforward. Compute networks win when supply matches a clear workload with guarantees customers can trust. Mapping and mobility networks work because contributors are already moving through the world. Hive Mapper turns normal driving into street-level imagery collection. Demo applies a similar idea to vehicle telemetry, connectivity, and ownership of car data. But the raw feed only becomes valuable after validation, coverage analysis, and packaging into datasets or APIs. Rewards should favor useful, fresh, geographically needed data, not just miles driven. The marketplace succeeds when buyers actually need those insights. Sensor DePIN turns physical measurements into data products customers can use. A weather station or positioning node is only the starting point. The network must prove that the device is real, correctly placed, calibrated, and reporting plausible readings. Then the data has to be cleaned, aggregated, and delivered through APIs or dashboards. The hard part is not collecting signals. It is producing reliable, standardized information that weather firms, logistics teams, construction companies, or mapping providers will pay for. A practical test for any DePIN network is simple. Can it prove the contribution actually happened? Wireless projects need credible coverage and location. Storage needs proof that data is held and retrievable. Compute needs verified results. Sensors need fresh, calibrated data. The challenge is doing this without inviting fraud, exposing users, or letting verification costs overwhelm the service. Token rewards are powerful for getting infrastructure online, but they do not automatically create a market. The harder step is converting capacity into paid demand. That means partnerships, developer tools, APIs, support, and enterprise trust. If supply grows faster than real usage, the network can look impressive while liquidity stays weak. Sustainable DePIN networks narrow that gap by focusing contributors on outputs customers will repeatedly pay for. Across these case studies, the stronger networks usually compound from a narrow starting market, infrastructure people actually need, and contributions that can be verified cleanly. Their economics reinforce real usage, not just participation. Failure patterns are the mirror image. Too much supply before demand, difficult hardware setup, unreliable service, and token emissions that attract speculation faster than customers. The practical test is simple. Does the network solve a paying problem better over time? Strong DePIN design starts with a focused market wedge and proves real customer value. Incentives should reward useful outputs, not empty deployment. Verification, onboarding, reliability, compliance, and economics make the network scalable. In the capstone, you'll turn these lessons into your own DePIN blueprint.